Hello guys, welcome to Pepcoding, and today we are gonna solve this question: cycle node in linked list. So there are two things. First of all, if you are watching this question directly, don't, because there is a prerequisite of this question, which is cycle present in linked list. The prerequisite. And before even this video, you have to watch a video which was the mathematical derivation and proof of cycle node in the linked list, which was done by Rajnisha. You can go and watch that video also. So after watching these two videos, come to this video again. So pause this video for now, watch them, and then come back again, because I will not explain you every little step of that of the derivation and proof of the cycle present in a linked list, right? So now let's get to our open board, and first of all I will explain you the question statement. After that we will start our question. Okay, so let's go to our open board. So the question is something like this. We already done is cycle present in a linked list, right? So in that question, what we have to do is, if there is any cycle present, return true. If there is no cycle present, return false. This was the question. But in this question, what our question wants from us is not just the true or false of even if not just the true or false. Question wants this node, the starting node of the linked list. Sorry, the starting node of our what? Tell me the starting node of our this time this time of the question wants the starting node of our cycle, not just the true and false, that if it is cycle or not. So if you remember from the derivation, there are some things. First is the formula, which was a is equal to c plus m minus 2n minus 1 bracket b plus c. That this was a formula. If you remember, what was m here? M was number of rotation of past pointer before meeting point. M is number of rotation of past pointer before meeting point, and n is number of rotation of slow pointer before meeting point. So you know, if you remember, in the linked list present, we take two pointers, fast and slow. What we have to do is we run fast with 2 times and slow with 1 time, and at some point they meet, right? And if they meet, we know that there is a cycle present, right? So m is what? M is number of rotations fast pointer did before meeting point. Now, n is what? Number of rotations of slow pointer before meeting point, right? Now understand some more things again. Can we say that B and C can never be 0? We can say that, right? Because if we can say that B plus C cannot be 0, because if B and C is 0, what will happen is length of B and C is 0. It means if B plus C is equal to 0, means no cycle present. No cycle present. Simple. Because if there is no length of B and C, then there is no cycle, right? So from that I can say that B plus C cannot be 0. So there are three things. Understand that there are A, then C, and then this equation. So B plus C cannot be 0. Okay. Now A can be 0, right? A can be 0 because there can be a linked list in such a way that it is cyclic, right? So A can be 0. But the fact is, first point is this, second point is A can be 0. But there's one more fact. If A can be 0, that means what? That means C must be 0. Must be 0. So if A is 0, C must be 0. That is simple. Why? Let me tell you how. So B plus C cannot be 0, right? So to make this equation come, if I'll say that 0 is equal to C plus minus 2n minus 1 and B plus C. So to make this equation 0, I can say that this cannot never be 0. And if even this is 0, to make this equation 0, we want C to be 0. To be 0. This is of a necessity, right? So if A can be 0, if A is 0, A and not even N, A is 0, B must be 0. Right? There are two things now. Now understand this thing. This is 0, this is 0. So I can say that M, let's take the color, change the color, M minus 2N minus 1, right, is equal to 0. I can say that, right? But if you remember, N is smaller than 1, and the rotation by small pointer, sorry, slow pointer is smaller than 1, or N must be greater than 0. So N is almost 0, right? So I can say that M minus 1 is equal to 0, and I can say that M is equal to 1. Isn't it right? So if N is equal to 0, M is also 0, M is 1, right? And I can prove you this. So for example, take this example. There is this linked list, something like this, cyclic, and I take slow and fast here, right? Slow and fast at the same point first for now. So first slow move, one rotation. Fast move, completely one rotation. One rotation is done. Then slow move to second move to this, and then fast here. Fast matches. Here's the meeting point. Right? So now you can say that, now what you can say that slow did what? Slow did one rotation, and fast did what? Two rotation, right? But no, the reality is slow did zero rotation and fast did one rotation, because second rotation of the fast is not considered, because at that rotation it is already meted. Fast meets the slow, so second rotation is not considered. Now let's take the example of 3 points. 1, 2, 3. Right. So this is something like this, something like this, something like this. Let's take slow and fast. Slow this side, fast this side. So slow move from here, fast move to here. Slow move to okay. Go back, go back, go back, go back, go back, go back. Fast move to here. Slow move to here. And fast move to 1, 2. Slow move to, okay, yeah. Slow is already what? Meted, right? So here fast also did one rotation. Fast did what? One rotation. Slow did what? Zero rotation. This is what the, okay. Now you understand this. Now let's go down and let's write our formula first. A is equal to, because everything is dependent in this formula. M minus 1 B plus C. This was the formula, right? We can drive this formula in this way. Because formula was this. N minus 1, which was like N is equal to 0. So M minus 1, we can drive our formula in this way. So from here, there are some things which I can see. So if okay, so let me check. If I say M is equal to 1, what is the value of A? A is equal to C, because this, if M is equal to 1, this will be 0. Second point. First point is this. Second point, if M is equal to what? 2, A is equal to C plus B plus C. Right? Third point, if M is equal to 3, is equal to what? C plus 2 of BC. So these are three questions which we can derive from this. But what does this mean? Right. So first of all, let me give you an example of this one. Let's make it out. So okay, this is our English, and I will make you example for this. Okay. So there will be 1, 2, 3, 4, 5, and then there will be 1, 2, 3, 4, 5, and 6. Right. So if A is equal to C, sorry, if M is equal to 1, so I will take what? I will take slow, fast, and I will move them. So slow move to 1, fast move to 2, again slow move to 1, fast move to, again slow move to 1, fast move to, slow move to 1, fast move to, slow move to, fast move to, slow move to 1, fast move to 2. Now see, slow move to 1, fast move to. This is our meeting point. This is our meeting point. Meeting point. I can see that, right? So if this is our meeting point, for M is equal to 1, M is what? Number of rotations of F. Number of rotations of F is 1, right? Because we did one rotation, and in the second rotation we meet the S. So what I can say that, and now count this. Count this. 1, 2, 3, 4, and 5. Right? And count this. 1, 2, 3, 4, 5. And if you remember, this was A and this was C. Right? If you remember correctly, this was A, this was C. So this term is, if M is equal to 1, A is equal to C. Right? Now let's take an example, bigger example for, let's take an example for bigger one. So let me take you red, take it 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay. So now let's take slow and fast again. Slow and fast. Let's move them. Slow one time. So before that, let me tell you what will be what will it be its meeting point. So its meeting point will be this will be its meeting point. How I know that? Just check it out. A is equal to C plus B plus C. C will be 1, 2, 3, 4. Right? 4 plus B plus C. B plus C is 7. 7 plus 4. So 1, 2, 3, 4, 5, 6, 7. 7 plus 4. So from here it will be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Right? And if I come here from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So meeting point will be this. Now let's check it out. Move S1, move F2, move S1, move F2, move S1. Okay. Move F2, 1, 2. Move S1, move F2, move S1, move F1, 2, move S1, move F2, 1 and 2. Then S1, F1 and 2. Then S1, then F1 and 2. Then S1, F1 and 2. Again S1. Now our F did like 2 rotations, right? 1 and 2. Our F is already did 2 rotations. Now check this out. 1 and 2 will go to this. F will go to this. This will go to this. F will go to, okay, this, and then this, and then this. Right? We got our meeting point. So now Now we will understand how we'll approach this question. We understand its mathematics behind it, right? Now check this out. If I take, if I grab this s from here and if I put it here at the starting, right? Then I start to run it one by one. See what will happen. S one time, F one time, one time, F one time, S again one time, F again one time, S one time, F one time. Okay, just it is taking, it is having some problem, so remove it. So let's check this out. So if this is the meeting point, just count. Just count. Like one, one, two, two, three, three, four, four, five, five, six, six, seven, seven, eight, eight, nine, nine, 10, 10, 11, and 11. So if I then if I take slow at head and if I start to move both of them simultaneously, at the end they will meet where? They will meet at the node which I wanted, right? So this is how we have to do it. So let's code it out. It's pretty simple. So let's make it full screen and start doing it. We will. So I'll tell you. First of all, the first thing we need to do is base case. So if head is equal to null, or if head dot next is equal to null, means what? If there is no head or if there is only head, means there is no cycle. Head alone cannot create a cycle. Then let's take slow and fast. Node slow is equal to head, and the list node fast is equal to head. Now while fast is not equal to null and fast dot next is not equal to null, we need to do something, right? We need to do what? Slow is equal to slow dot next and fast is equal to fast dot next. Why we are doing it? Tell me why we are doing it. So first of all, we need to understand, we need to find if there is even any cycle exist or not. So for that we are writing this code, right? If our cycle exists, our slow and fast will meet someday. So if slow is equal to fast, like if they meet, we want to do what? Break. I just want to break this loop. So now coming from the loop, there are two ways to breaking this loop. First is our fast get to null and our linked list is exhausted, right? And the second is our slow is equal to fast. So I know that if slow is not equal to fast, that means what? That means our linked list was linear. So we will return null because there is no cycle. But if the cycle exists, what we will do? First of all, we make slow as head. This was our first thing we need to do. And the second thing we need to do is while slow is not equal to fast, we need to run. Like slow is equal to slow dot next and fast is equal to dot next, right? And at the end, we don't need to return null, we need to return slow or fast. Like you can return anything, you can return slow or fast because both are the same node which we wanted. Right? So now let's try to run this code. If there's any compilation error, we'll solve it. And if everything is fine, we'll run it. So now let's check if there's any compilation error. Okay, accepted. Let's submit this code. Okay. It is taking longer. Okay, so our code is perfectly fine. It is working correctly. So if you understand my uh, concept, to understand this concept, please like the video. If you have any query regarding this, then please comment it out. And if you have any query, just comment it out and I will solve it. And the last thing is, please subscribe to our channel. Thank you so much, guys.